Welcome back. We're writing Little Man Computer in C++, and last time we wrote something a little bit more high level for assembling a file in a single instruction from the disk. We'll have a look and see what we did there. Just to remind myself, assuming I can remember where we put anything. So we just developed this assemble function here that takes a file and returns a list of instruction values. And what I kind of want to do today is just to create a main function without tests for now, just to see how far away we are from having something that we can put together. So if I look at our assembler here, we have the ability to just call assemble with a file, and that will return a list of instructions. Then there is a little man that takes a computer, and we can then load a program and run it. And all of that looks relatively straightforward, with the exception of creating this input and output stream type for handling real I/O. So let's have a quick look and see what files we've got there. So I think we can create just an LMC CPP here. So if we were to do this, and for now I'm just going to create a placeholder main. I'm not sure the proper way of doing this in C++, so let's just have a quick look. I want to get the arguments as really I want to get the arguments as list of strings, but I don't think you can do that. You have to use this sort of more C-like formulation, which is fine. And we'll see what that does. Oh, that's interesting. You can do this, which is intriguing. But let's just put this together first. Is it so int number of arguments and I've seen that presented in a few different ways, but for now we'll do it that way. So that gives us a main function. Let us edit the makefile so that we can build this, and we want to do, I feel like I should put it up here. So that LMC would be based on lmc.cpp, and all of these things eventually, and then all of this should just be the same, I think. That looks completely plausible. And of course, on our build, we also want to build LMC. So if I were to run make now, will that build okay for us? What have I done there? Ah, yes. Nearly. That might be a little bit more accurate. Unused parameters, that's fine. Let us do this. for now. I just want to get to the point where it's compiling and everything's happy before I do anything further. That looks okay, and if I were to drop out of this, I should be able to do that. That's excellent. Good. Very nice. So I want to include all of the component parts in here. So we'll have a computer, little man, and our assembler. I think that's okay. Let's just check that I've included them correctly. Looks fine. And then in here, what I'm going to do temporarily is just run our sample program. So we should be able to say instructions, assemble sample.lmc. We won't worry about dealing with the command line arguments just yet. And then we need a computer, like so. And we need a little man. I don't actually remember. What. Oh, that's interesting. It's doing something a little bit different. Our little man is called little man. Okay. And we need a little man, and that takes a computer, I think. Let's go to the buffer number 4 after writing, and takes an input stream and an output stream. So we'll need to create those as well. Let's see what my memory is like. Yeah. Let's get there. And let's store that. So we need to create a class of standard input stream. Is that how you do it? Actually don't know. Let's get rid of that temporarily, as it's not quite ready yet. And see if that's what we want. So now we need to implement our, should we do it that way? Yep. To implement that, and the same here. I'm somewhat making up whether this is the way that you do this, as I can't remember. So that's the kind of thing we'd like, and we'll see how horribly wrong that is. No type main computer, of course there isn't. That is uppercase. We have missing semicolons, unused variables, all of the usual kind of thing. So how do we do this? We want to include IOStream. Let's put those at the top, and that will be something like we want, how do you do this? Int next. Oh, is it the other way around? Like that? Could be. And output hopefully will be just cout output, and let's actually do those things as well. And I suspect we need to do the same here. So let's see if that's the right thing. Output stream. Yep, that makes sense. Ooh. Like so. Let's see what that does. That looks like it's okay. So we should be able to then say little man with a computer, order of these things in, a input stream and then an output stream. So input stream and output stream. No idea if you can declare these directly here. We'll find out in a moment. Candidate construct. Oh, if it's a constructor, I probably need to do that, or at least something similar. All right. And now what we've done. So no matching constructor for initialization of little man. Ah, that wants to be a shared pointer. Okay, that's a shame. So let us create input stream equals, how do you make a shared? Make shared, be something to that effect, won't it? Standard make shared. I suspect we'll be able to guess this from just that information. Looks plausible. Like so. I don't really like those names, but we'll make do for now. And that's input stream. Output stream. A sluggish shift key there, not working very well. How many errors have we got now? No matching constructor for initialization of little man. So what have we done wrong? So it takes a computer and an input stream and an output stream. That's interesting. We have a computer, we have an input stream, we have an output stream. What was the exact error message? It's not really going to give us anything useful to go on there, is it? No matching constructor for initialization of little man. Let us have a look at those tests and see what we've done. It's run like that here. That's interesting. So let's go back to this setup here and see. So that's doing the same thing as we are here. That looks very similar. Can we see the difference? Do I need the public bit on the front there? Maybe. I can't imagine that's a requirement, is it? Ah, yes, because then it won't know what type it is, maybe. There we go. Good. So that's a step nearer. We have this. Let me just do things in slightly different order there. So that's our little man. We've got some instructions. We then can say load program instructions, is it? I want to say something like that, and then man.run. Let us have a quick look. Load program and run. So that looks quite similar to what we want to say for now. Good. The question is though, does it actually do what it's supposed to do? Should print out some numbers. And I have a suspicion that's got stuck in some sort of infinite loop. Ah, no. Was that requiring an input if I put 4? Yes. Some sort of prompt might be kind of useful. Let's go back and put that in. So if we were to say something like that, just to show that there's an input due, and then if we do that, oh, very nice. Isn't that good? So that actually works. And then the final thing to do is to handle the input here, and that's going to be something like if argc is not equal to, how does that work? 2? Do we have one for the program name as well? I think we probably do. We can then say cout usage, and then argv0 input. That'll do for now. Oh, and then I don't know, that's something like that. And then how do we create a string? I'm just going to completely guess something here, which is not really what you're supposed to do. And just say something like this. For amusement. No idea whether that's in any way legal. But it feels like what the API might be. And it's easier than going and looking on the internet. Well, it hasn't died horribly. So if we drop to there, that'll say we want that. Oh, lovely. Well, there we go. So what have we done there? We have created our input stream from standard in, which prompts us for an integer. No error handling there at all, of course. We then take an output. We create an output stream, so standard out that does the same thing the other way around, and then we parse our input. We create a computer with input stream. We create an input stream and output stream and create a little man. We then assemble the instructions from the file. We load the program, we run. This looks a little verbose. We may be able to do something better with that. But for now, I think that's okay. So I'm happy with that. And I think I'm gonna commit those changes as that works. What is our status? We have to update the getIgnore. Like so. Nice. Well, that's happy. I should be ready to go. Add main program. I think that says all we need to say there. And let's just run that one more time for fun. How far can we push it? We can push it quite far. And we'll see where we want to go with that next time.